Slimy remains from microscopic organisms on the seafloor can trigger catastrophic tsunamis, researchers have found. Scientists have finally learned of a potential cause for submarine landslides, according to a new report from the Helmholtz Centre for Ocean Research Kiel. The cause for the landslides, that are often much more destructive than those on the shore, was previously a mystery. But researchers combined seismic data with seafloor samples collected by the ocean drilling program to deduce that a slime left behind by microalgae might be causing the potentially disastrous shifts in the Earth's crust. Scroll down for video. The report, published in research journal Geology, explained how landslides in the ocean are of a different scale than those on land. It said, when the seabed loses its stability and starts to move, it often happens in much larger dimensions than landslides ashore, and at slopes with very low gradients. Study author Dr. Morelia Erlob explained, submarine landslides happen on very shallow slopes, often with gradients as low as 1 or 1.5 degrees. But much damage can be done even when a landslide occurs on a fairly flat surface, the report explained. Displacement of large amounts of sediment underwater can cause devastating tsunamis. Before now, scientists knew very little about why submarine landslides occurred, but the new research marks a step toward figuring out what causes them. The ability to predict these landslides, which could stem from the new report, has the potential to help map out the safety risks of offshore endeavors. The report said, searching for the causes of such landslides is much more difficult underwater than on land due to their inaccessibility. Additionally, the report clarified that researchers still do not fully know why the landslides happen. It stated, why and when submarine landslides develop is hardly understood. But, it said, the outcome of this study may help to identify areas which are prone to landslides. The team from the Helmholtz Centre referenced 2 submarine landslides in the new report. One took place 8,150 years ago and displaced an area of the seafloor that is larger than Scotland. It resulted in a tsunami that was up to 65.6 feet tall, which hit Norway and the Shetland Islands particularly hard. It is referred to as the Storge landslide, and the researchers said it could have taken place up to 6,561 feet below sea level. The Storge landslide affected an area larger than Scotland, and the material today covers hundreds of kilometers on the seabed, the report said. But the data analyzed for the new study was based on a submarine landslide that took place off the coast of Mauritania in northwest Africa. The researchers combined results from drilling with seismic data and were able to show that a certain stratification of the seafloor was responsible for at least one slide in this region, the report said. The slope of the area affected by the Storge landslide was just 1.6 degrees, but the landslide off the Mauritanian coast had a slope that was, at most, 2.8 degrees. The report explained the logistics of a submarine landslide. It said, when a layer gives way, all overlying layers move down the slope. It is difficult to determine the composition of this particular layer because it is destroyed with a landslide. This conundrum has kept researchers from understanding the causes of underwater landslides until now. But Dr. Erlob's team was able to develop research based on seafloor samples and seismic data to come up with a new theory. In the case of the landslide near northwest Africa, portions of the slope involved in the shift were still intact. This allowed Dr. Erlob to analyze the exact composition of the sediment at the scene. We were able to use these old 1980s cores to look for the weak point in the slope, she explained. The combination of this drilling and seismic data showed that the slope was slipping just where a clay layer overlays ooze made up of the remains of fossil planktonic organisms, the report said. The ooze the researchers analyzed mainly consisted of diatoms, microalgae that are some of the most common categories of phytoplankton. The scientists ultimately learned that the ooze allowed for the eventual collapse of the seafloor. It explained, these phytoplankton organisms form shells out of silica. In some phases of the Earth's history, large amounts of diatoms form, the shells of which, after dying, sink to the bottom of the sea and form thick layers. Since diatomaceous oozes appear to be a common feature off the northwest African coast as observed in seismic data, the authors assume that this phenomenon is also the reason for other megaslides in the region. The research is the first of its kind to suggest ooze as a possible answer to the cause of oceanic landslides.